Hello. In this video, we're going to go over finding all six trig values and ratios given a coordinate point. The first thing we're going to do is graph the coordinate point. So let's graph it. We draw a coordinate plane and we go to the point where it's x, y, -3, -4. 1, 2, 3, 1, 2, 3, 4. Next, you're just going to create that straight line from the vertex of 0, 0. And create a straight line down to our point. We have created a mini triangle. I will relay this with different colors. There's our mini triangle. We know that within the triangle that we went -3 to the left and -4 down. Next, we just need to find the hypotenuse. In order to find the hypotenuse, we use Pythagorean theorem. -3 squared plus -4 squared is equal to c squared, or I like to just call it hypotenuse squared or hype squared. At this point, we see 9 plus 16 equals the hypotenuse squared. We'll square root both sides, and we see the square root of 25 equals the hypotenuse, which is 5. We can replace this value now with 5. At this point, we have done sufficient background information to now solve for our 6 trig figures. First, we have the sine of theta, the cosine of theta, and the tangent of theta. Then we have their inverses, cosecant of theta, secant of theta, cotangent of theta. We remember what these ratios are through SOH-CAH-TOA. SOH-CAH-TOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So the sine of theta is equal to, and this is our angle of theta, is equal to the opposite over the hypotenuse, -4 over 5. And before we move on to cosine, all I'm going to do to find the inverse of sine, or the cosecant, is just flip that fraction. And that is all. The cosine of theta is adjacent or next to over hypotenuse. And we see that as -3 over 5. To find the secant, we're just going to flip that fraction. 5 over negative. -5 over 3. Tangent, again, is opposite over adjacent. So -4 over -3 for 4 over 3. Cotangent will be the flipped version, 3 over 4. So those are the 6 values, 6 trig value ratios, just given one coordinate point. We can do this for every single point and create those types of triangles. If we can double check now with all students take calculus, we know that only tangent should be positive in the third quadrant, which is where we lock. And if we double check, tangent is the only one positive, cosine and sine are both negative. If there's a specific problem you'd like me to cover, please send me an email. Other than that, hope everyone has a great day.